So, continuation of the lecture 2. This is the lecture 3, is the final. All non-parametric methods are covered in 3 lecture videos. These are very useful for all examinations related to statistics and also data analysis. Who are preparing for semester end examinations, other examinations, competitive examinations, entrance examinations, these lectures are very useful. The lecture number 3 contains here, includes test number 3, that is Wilcoxon signed rank test. Several steps are there, simple steps are given as compared to original procedures. For examination point of view, students can easily understand the concept of this Wilcoxon signed rank test. It is same as to sign test, but some simple modifications in the sign test by assigning the ranks to the deviations. Subtract the median value from each and every observations, we get positive deviations and negative deviations. Sometimes maybe 0. 0 is dropped here from this procedure. Based on these positive deviations and negative deviations, find out the ranks of these deviations and use the systematic procedure to analyze the data. Now step 1 here, that is null hypothesis. This is a very useful concept. Null hypothesis is the median, the specified value, the median value is greater than or equal to some specified value. What is the meaning of some specified value? Based on the problem, so one number is given, that is median. The median is specified value. Our H0 is, there is no significance difference between the population median and also specified value, sample median. No difference between population median and also sample median. Here in this case, the population median is more than or equal to some specified value, or population median is less than or equal to some specified value. Here use this less than case, less than or equal to, no problem here, either this or that. Finally, the population median is equal to some specified value. The null hypothesis may be simple to composite. This is simple one, these two are the composite. Now alternative is the complementary of null hypothesis. MD is less than median, it is quite complementary of, here is greater than equal to, here is less than. The population median less than some specified value, or median is greater than MD naught. MD not equal to population median, not equal to sample median, that is called subspecified value. So first 2 steps are for all these parametric, non-parametric test. Now there is 5 steps are there in the any statistical testing procedure, either parametric or non-parametric, whatever here. So now this is in non-parametric also, step 1 step is null hypothesis and alternative hypothesis. Choose level of significance, alpha % level of significance. Now 4th step is the signed rank test procedure. N is less than or equal to 30, small sample case. Suppose your collected or obtained data is less than or equal to 30, it is called a small sample. That is the based on the, so one specified levels, eminent personalities are decided this small sample and large sample based on the sample size. If sample size less than or equal to 30 is small sample, more than 30 is a large sample. For suppose your data contains less than 30 samples, how can perform this signed rank test? Already explained the same procedure to the sign test also. In this signed rank test procedure, first step is subtract that given or specified median value. This is a given value or specified value. Here is from each observed value here, from each observed value. So So this is the specified value. You subtract the specified value from given set of numbers. Some 20 numbers, 30 numbers, below 30 here. 10 numbers also here. I will give the one example related to this signed rank test. That is also very useful to understand the concept of the signed rank test. So discard zeros here. Discard by subtracting the specified value from each observation. Sometimes maybe that observed value, that is median MD naught, is same as to observation value, that deviation is 0. So those type of zeros are there in the procedure. Now you have to discard that zeros. How many zeros are there? You have to discard all zeros and modify the sample size. Suppose 2 zeros are there in the process. Now you have to discard the 2 zeros from the total sample observations. Suppose 11 observations are given, 2 zeros are there, 11 minus 2, 9 is the final sample space. Assign the sign rank to each of the remaining differences. So positive differences are there, negative differences are there. After dropping the zeros, deviations either positive or negative. Now you have to compute the T plus and T minus here. Some of the positive ranks, sum of absolute value of the sum of the negative ranks. So there is a negative ranks, you have to apply the modulus. After that you have to assign the ranks, and after that you have to take the sum, that is T minus. T plus is the sum of the positive ranks. First of all you have to go through the procedure. After that you have to take the problem. Easily you can understand this concept. So not only for this semester examinations or the other examinations, but for data analysis purpose, this is very useful here. Now T minus is the sum of the absolute value of the sum of negative ranks. Here you have to calculate this too after assigning the ranks. Next, fifth step is one here, test statistics. You have to calculate test statistics. That is called a simple mathematical technique. There is a minimum of T plus and T minus. The minimum of T plus and T minus. Minimum of T plus and T minus. So now this value is equal to T naught. That is T naught, say. You remember that point here. That value is equal to minimum of these two is T naught. So now fifth step here, fifth main step, if T naught less than or equal to this calculated value is less than or equal to signed rank, Wilcoxon signed rank table values are available. Go through the table values. I will provide the table values. I will forward the table values. So now here based on this table value also available in in Google. You can also search these table values using any platform. So now download that signed rank test table values. So compare with T calculation value with T table values, signed table values less than, reverse case of the parametric test. In parametric test, Z calculation less than or equal to Z table value, we fail to reject H naught, otherwise we accept H naught. That is called, we reject H naught. But in this case, the T naught, the T calculation value less than or equal to signed rank table value, reject H naught. A reverse case. Compared to parametric is a reverse case. So if T naught is greater than signed rank table value, then H naught may be regarded as true. But in this case, accept. This is H naught is maybe H naught may be accepted. That is called here. So see the difference of these two. This is the main procedure. Now go through this procedure and solve this problem. Here suppose n is greater than 30. In this case, one more step is added. For the single procedure, you have to learn how to perform the signed rank test when n is less than or equal to 30, n is more than 30. Step number 6, signed rank test procedure, n greater than 30. So last sample case. So test statistics. Z is given here. Z is given. Now Z is equal to Z formula T minus mean of T by standard deviation of T is follows n of 0, 1 standard normal variate. So this is capital T is the minimum of T plus and T minus, already calculated in step number 4. So now calculate the mean of T using this formula, n into n plus 1 by 2. After discarding zeros, you have to modify the size of the sample. So based on the number of zeros in the procedure, after discarding zeros, how many deviations are there in the process, that is the final n value. Here is n into n plus 1 by 4. Standard deviation of T is the square root of n into n plus 1 to n plus 1 by 24. Step number 7 is final. That is step number 7. If Z calculation less than or equal to Z table value, so we fail to reject H0, otherwise we reject H0. This is the parametric model here. When sample size is more than 30, automatically this procedure transform to Z test. Transform to Z test. That is very beautiful concept. Now go to the problem here. This is the problem related to Wilcoxon sign rank test. So this is a real problem, is a case study, is a simple case study. The following are the responses to the question. So I am asking the question to all students here. How many hours do you study before the major statistics subject or mathematics subject, whatever here. I collected these 12 samples from the students. One student respond 6 hours, other student respond 5 hours, last student respond 7 hours. Use Wilcoxon sign rank test. So you can apply any test, but sign rank test is useful for this problem to test the hypothesis at 5% LOS that the median number of hours of study before major mathematics test is 3 hours. Median hours is 3 hours. So before 3 is 50% of the students, after 3 50% of the students. Some students complete the whole syllabus within the 3 hours time. Some of the other students complete the whole syllabus takes more than 3 hours here. Is it correct or not here? Based on this sample. This samples is collected from the students here. Is it correct or not here? Based on this number. You have to check this statement at 5% LOS. Now here is step number 1. Step number 1. So H0, MD is equal to median. Specified value 3 hours is given in the problem. So now alternate hypothesis. Actually we have to, that median value is 3 or not here. So there is no condition in this problem here, direct question. So MD is not equal to 3 hours. Alpha is 5% LOS, N is equal to 12 samples is given. So N less than 30, use small sample case. Here N is less than 30, use small sample case. Now subtract 3 from each observation, we get this deviations. So here is the first number is 6 minus 3, 5 minus 3, 2. So here is 1 minus 3 minus 2 minus 1, 2, 4, 2, 0, 4, 1, 4. 1 0 is there. Now discard this 0. Now discard this 0. Here 0 here. Now after that sample size is so adjusted sample size is 11. So new sample size is 11. Increasing order of their absolute values. So now here you have to arrange the data in increasing order based on the applying the absolute values. Minus 2, minus 1, minus 1. Here apply the modulus value minus 1, it is treating as a plus 1. Apply the modulus to minus 2, it is treating as a plus 2. Now based on the order, so 1 is there, this is a positive deviation. By increasing order, minus 1, 1, minus 2, because minus 2 is a 2 when applying the modulus value. That's why here arrange the minus 2 is the after 1 here. 1 is a positive deviation, minus 2 is a negative deviation. After applying the modulus for this number, automatically this number is more than this 1 here. The remaining deviations are positive deviations. Based on the increasing order, I noted this sequence. Now here assign the ranks. So here is minus 1 is treating as a 1, minus 1 is treating as a 1, 1 is a 1. Now assign the ranks. How to assign the ranks? Already explained in this concept in the correlation, Spearman's rank correlation chapter. Based on that procedure, you have to assign the ranks to the numbers here. So now assign the first rank to least number, assign the next rank to next least number. Likewise, you have to complete the assign the ranks to the assign all observations, all deviations. Now this is first three numbers are same. Assign the first rank, second rank and third rank, and find out the average of these three ranks here. Based on the Spearman's rank correlation techniques, you have to find the common ranking, that is called average ranking. 1 plus 2 plus 3, that is 6, 6 by 3 is the 2. Assign the second rank to each and every value of the 1, 1, 1. So next rank goes to 4. So 4, 5, 6, 7, because of there are 4 2s are there. In this case here all are repeated observations. In this case we have to assign the ranks. So now common rankings. 4, 5, 6 average is 5.5. Assign the 5.5 ranks to each and every 2s. Deviation 2. Next rank goes to third, next observation 3. So is only one time here. 3 is occurs only one time. Assign the directly 8th rank. Next to 4 occurs 3 times. You have to assign the common ranking. In this case 9th, 10th, 11th rank is assigned. So average of these 3 is the 10, 10, 10. Now ranking procedure is completed. Now corresponding deviations for this rank. For this second rank, this is a -2. This is the -2. For this rank, this is a +2. 5.5, this is a minus. Here is this 5.2 belongs to -2. That's why here you have to assign the negative sign. Remaining are positive signs. Now T plus, some of the positive ranks. Now positive observations here 1, 2, 3, 4, 5, 6, 7, 8 here. So now by combining all these two, that T plus value 56.5. T minus value is the 9.5. So now here is test statistics T now. Minimum of these two, T plus T minus. The minimum of 56.5, 9.6, 9.5. That is the minimum is 9.5. Now the sign rank table value, T table value. So n is 11. So after discarding 0, actually n is 12. After discarding 1 0, that sample size is 11. 11 at 5% level. From the table, that value is equal to 11. So the T calculation value 9.5 less than T table value, we reject H0 based on the step number 5. We conclude that the median number of hours of study before major mathematics test is not 3 hours. Is not 3 hours. This is the final result. So go through this problem, easily we can understand the concept. So next another one here, Mann-Whitney test. That is test number 4 is also very useful for comparing two population medians. You have to use this Mann-Whitney test. Step 1, set up null hypothesis. H0, the population median of population 1 is greater than or equal to the median of population 2 or less than or equal. This is the null hypothesis. There are 3 cases are there. Any one case may be happen here. The first 2 cases are composite hypothesis. Last one is the simple hypothesis. Alternative hypothesis, quite complementary to the null hypothesis, is called alternative hypothesis. Here is the population median of X is less than population median of Y is more than, here is not equal. Choose alpha % level of significance. For this case, when we have to use the Mann-Whitney test, 2 populations are there, 2 samples are collected from the 2 population. There is no significance difference between the medians of the 2 populations. So alternative hypothesis, there is some significance difference between the 2 population medians. So different cases are there here. Now alpha percentage, choose either 1% or 5%. Test procedure for a small sample case. Small sample case. N less than or equal to 30. So combine the observations of both samples to obtain a single sample. So X population data is given, Y population data is given. So X is belongs to one place here, one classroom. So Y is the another classroom. So 2 sample data are available. Combine these 2 sample data. So obtain the single sample. After that, arrange the data in ascending order. After that, arrange the data in ascending order means smallest to biggest. their magnitude because of plus signs or minus signs. Arrange the data in ascending order. After that, assigning the ranks to the combined sample data and find the values of Tx, Ty, Ux, Uy defined as what is Tx, what is Ty, what is Ux, what is Uy. Tx is equal to sum of the ranks of the observations of the first sample, means x variable. You have to find out the sum of the ranks of the observations of the first sample. First sample means x sample values in the combined sample. After combining, you have to give the ranks. So some ranks are there for x variable values and y variable values. Now you have to calculate Tx and Ty. How to calculate Tx and Ty? Tx is the sum of the ranks of the observations of the first sample in the combined sample. Ty is the sum of the ranks of the observations of the second sample, y variable in the combined sample. So how to calculate Ux? Ux is there is a mathematical formula. Tx is already calculated. Tx minus n1 into n1 plus 1 by 2. n1 is the size of the sample x. n2 is the size of the sample y. So now here Ux, Uy. After that you have to calculate the test statistics. After these two, you have to calculate the U. U is depends upon Ux and Uy. Ux, Uy depends upon Tx, Ty. You remember that point here. U is equal to minimum of Ux, Uy. That is called U naught. That is same. So step number 5, reject H naught. If U less than or equal to U table values. This table value also available. So now I will provide this table value. I will forward these table values here. Man-Whitney U table value also available in Google. You have to Google search. You have to download these U table values. So your calculation value, U calculation value based on this formula, minimum of Ux, Uy. So U calculation value less than or equal to U table value. So reject H naught. So next one, fail to reject H naught, U greater than U table value. For large sample case, n is greater than 30, so use Z statistics. So Z is equal to U minus mean of U by standard deviation of U is follows normal distribution, you know very well. For large case, either parametric case or non-parametric case, based on the central limit theorem, this for large case, any parametric test, any non-parametric test, compulsory follows to standard normal distribution. In this case, use Z test. The formula is given. The mean of U is equal to n1 n2 by 2. Standard deviation is square root of n1 n2 into n1 plus n2 plus 1 by 12. So now similar procedure for concluding remarks. In step number 7, if mod Z calculation less than or equal to Z table value at 5% level of significance, Z table value at 5% level of significance is 1.96 for two-tail test. For one-tail test, 1.645. 1% case 2.58, 2.33, so respectively. So in this case, we fail to reject H naught, otherwise we reject H naught. So one problem is required for understanding of the Man-Whitney U test. So now for the following data, test the hypothesis that the median measure in the population of X is less than the median measure of population Y. This is a statement. This is the null hypothesis. The median measure in the population X is less than the median measure in the population Y. Using the Man-Whitney test, so you have to analyze the data here at 5% LOS. X values are given, Y values are given. Step 1 H naught, the population, the median of the population X is this is the given hypothesis. This is neutral. Always the given hypothesis not in neutral here, null hypothesis. Null hypothesis, neutral hypothesis. Null hypothesis means neutral hypothesis. You remember that point here. So based on the requirement to test the median measure in the population X is less than the median measure in the population Y. This is actually favored to X or not favored to X is favored to Y here. But this is not a neutrality. Why we have to take this statement in the alternative means here this is a neutral, this is not a neutrality. Neutrality means here both are not equally good here. Sometimes it may be more than. Actually, based on the given one, alternative hypothesis, the population, median of the population X is less than median of population Y. To test this statement, which statement to be tested, that must be in the alternative hypothesis. The complementary of null hypothesis is the strictly greater than equal to. Remember that point. Alpha is equal to 5% level, N1 is equal to 4, N2 is equal to 7, N1 plus N2 is equal to capital N, that is 11. 11 is less than 30. Last small sample case. Small sample case, use this formula. Now, what is the procedure here? First of all, you have to combine the all sample values. So now here is the minimum is 8. This is a first sample. This is a second sample. So this is third one. This is fourth one. This is fifth one. This is sixth one. Seventh one. Here is next eighth one. This is ninth. This is 10th. This is 11th one. Increase the numbers like this. So you see this one 8, 10, 20, 23, 25, 32, 32, 6th and 7. So first of all you have to assign the order numbers. After that you have to combine the sample data. Next one is 45, 54, 54 belongs to the Y variable, 60. Finally Y is equal to 65. Now the data is combined and identify this variable, this observation belongs to which variable. Identify this 8 from Y, so 10 from Y, 20 from Y, 23 from X, 25 belongs to Y here, 32 Y, this 32 is X, 45 is X, like this. Now here assign the ranks here. Least number, assign the first rank to the here, second rank, this is third rank, this is fourth rank, this is fifth rank, but here is 32 occurs twice and 6 and 7. Average of these two is 6.5. This is 8th rank, 9th rank, 10th rank, 11th rank, like this. Common ranking also assigned here, each and for when the observation repeated twice and thrice, you can apply the common ranking system. Already explained in the Spearman's rank correlation procedure. You know very well that concept is included in the correlation chapter. So TX is what here? Sum of the ranks of the first sample, that is called X variable values. Here TX means sum of the ranks of the X, sum of the ranks of the X variable, sum of the ranks of the variable. This is 4 from X, here is 6.5, here is 8, and finally 10. That is 28.5. TY 1 plus 2 plus 3 plus 5 plus 6.5 plus 9 plus 11, that is 37.5. Now calculate. UX depends on TX, UY depends on TY, and also sample size. TX minus N1 into N1 plus 1 by 2, that is 28.5 minus 4 into 5 by 2, the result is 18.5. You know very well, it is a very simple calculation. So even non-mathematics students also easily can understand these concepts here. Especially for this topic is very useful for non-mathematics students. UY is equal to TY minus N2 plus 1 by 2. So simple mathematical techniques are used in this procedure. 37.5 minus 7 into 8 by 2, that is 26. After 28, after that this is 9.5. U statistics is very important, that U depends on UX-UY, UX-UY depends on TX-TY. Now calculate test statistics. U is equal to minimum of 18.5, comma 9.5. This is 9.5. Now Step number 5 is use statistics U table value at 5% LOS. N1 is equal to 4, N2 is equal to 7. That is 4 U table value is available. So in the Google search to U table value, I will also provide these table values. So U calculation value 9.5, U table value is 4. U calculation value is greater than U table value. We fail to reject H0, that is accept H0. Go through the procedure and see the comments on that step number 5. At the 5% LOS, we conclude that the median measure of the population Xn via same. Actually, this given here that median measure of the population X is less than the median measure of the population Y. That is a given tested statement, but is not correct. That is rejected. We fail to reject the H0. Here H0 is what here? The median measure of the population X is more than or equal to Y, because of both are same here. Now here is next one is another non-parametric methods are is completed. All tests are completed. Problems on chi-square test is also very useful for examination point of view. Two researchers adopted different sampling techniques while investigating the same group of students to find the number of students failing in different intelligence levels. That results are as follows. So now this two-way cross table is given. So for data analysis is very important problem. Researcher X and Y, there are two researchers and different two classifications are there. One is researcher classification, other is number of students in each level here. So different levels are there. One is first level is below average, average, second level, third level is above average, finally genius. So data is collected from the sources here. So now this is the problem here. First of all, you have to find the row totals, and next you have to find the column totals. Sum of the row totals will be equal to sum of the column totals. That is Kaplan is equal to 300. Would you say that the sampling techniques adopted by the two researchers are significantly? The sampling techniques adopted by the two researchers are significantly different. The researcher X, researcher Y collect the information from the source. Two different classifications. The researcher main objective is test the student levels. For different classifications are there. One is below average, average, above average, genius. So different sampling techniques are used to collect this information. These sampling techniques adopted by the researcher X and researcher Y is same or not? Both are researchers used the same techniques or different techniques. That is the main our requirement. So now chi-square test for independence of attributes. So this is the quality purpose. You have to use chi-square test. H0 independent of the sampling techniques adopted by the two researchers. Two researchers sampling techniques are independent, not same here. Sampling techniques are not same adopted by the two researchers. That is the main H0. So there is a significant difference between the sampling techniques used by the two researchers for the collecting the required data. Some difference is there here. Both are independent. The sampling technique 1, the sampling technique 2 adopted by the researcher XY, this is independent. But alternatively there is a significant difference between the sampling techniques used by the two researchers for collecting required data. Some relation is there. Alpha is 5% LOS, so based on the formula. Now here is degrees of freedom is very important. How to calculate degrees of freedom for cross tables? So it depends upon the number of rows and columns. You have to calculate the degrees of freedom. What is the formula here? Now the formula is R minus 1 into C minus 1. R is row, number of rows minus 1 into number of columns minus 1. That gives the degrees of freedom. For this problem there are 2 rows, 2 minus 1, columns is 4, 4 minus 1, 3. 1 into 3 is the 3 degrees of freedom is a initially. Before calculation, this degrees of freedom is maybe before taking the table values, sometimes this degrees of freedom may be modified based on the several constraints. I will explain here. Calculation of expected frequencies. To test the chi-square test, expected frequencies are required for cost tables. Now expected frequencies are required here. So now this from here like this, for example, several rows are there here, different columns are there. This is the first row, second row, third row, 1, 2, 3, 4 columns here. These are the O11, O12, this is O13, O14, O21, O22, O23, O24, O31, O32, O33, O34. So now this is the observed frequencies. Immediately you have to calculate for each and every cell, you have to calculate the expected frequencies corresponding over 1 expected frequency E11. How to calculate this one? First row total multiply first column total dividing by capital N. First row total multiply with first column total dividing by capital N. Dividing by capital N. That gives expected value. That is a formula. So now here is corresponding E12, E13, E14, E21, E22, E23, E24, E31, E32, E33, E34. After that you have to calculate the chi-square value. So procedure is given based on the our 2/4 cross table. You have to calculate the expected frequencies using the cell frequencies. So how to calculate expected frequency of 86? Row total is 200, column total is 126. Is already computed before taking this expected values. 200 into 126 by 300, that gives 84. Similarly, you have to calculate the expected frequencies of 60 and 44 and 19. After first row is completed, you have to calculate the second row expected frequencies using the short technique. Total is there here. Total means total minus first cell expected frequency give. So second row first cell expected value is obtained. So 126 minus 84 gives 42. 93 minus 62 gives 31, like this here. Now these all are computed. After that, expected frequencies. This is called E11. This is E12, E13. This is E14, E21, E22, E23, E24. Corresponding O11, O12, O13, O14, O21, O22, O23, O24. This is a very important one. This is damn sure question. 10 marks problem in the semester examinations is very important. Computation of chi-square value. Now OS and ES. So OS are given observed values, given frequencies. This is expected frequencies. Calculated values, expected frequencies. Remember these 2 points here, 2 differences here. Expected frequencies. So column wise you have to note this one. Any one of the expected frequencies is less than 5. That value, any one of the expected frequencies less than 5, it should be made into more than 5. In this case, you have to use one procedure. That procedure is what? So you have to add this, whichever expected frequency is less than 5, that frequency added to preceding or succeeding. But in this problem, so preceding value is there. This is because of this expected frequency is the last one here. Now here add 4 to the preceding of 23, that make into 27. So one constraint is there. You have to lose 1 point from the degrees of freedom. Already degrees of freedom is 3 calculated, row minus 1 into column minus 1. That value is equal to 3. 3 minus 1 is the 2. Now degrees of freedom 2 for this problem. Now we have to calculate the OA minus EI. Simply technique. Observed value minus expected value. Differences is calculated 2 minus 2 minus 2 2, 40 minus 42 minus 2, 33 minus 31 2, 25, 27 minus 27 is 0. Whenever you pooling the expected frequencies, automatically corresponding observed frequencies also to be fold. That is very important one. So after this one, you have to calculate OA minus EA whole square. Square of this values, 2 square is 4, minus 2 square is 4, like this. After that, you have to calculate the OA minus EI by EI. So fourth column dividing by second column. This is the column 1. This is the column 1, column 2, column 3, column 4, column 5. How to get column 5? Fourth column dividing by second column. Square of the third column is fourth column. Fifth column, how to get here? Fourth column dividing by second column. After that, this total of this value is called chi-square formula. The chi-square formula is given here. Chi-square calculation value 0.923. Already chi-square table values is given. Go through the chi-square table values. Degrees of freedom is, so n is degrees of freedom. That is called degrees of freedom. This is 2. Here is 0.05. The corresponding table value, how much here? 5.991. Go through the table value. The chi-square table value is 5.99. Chi-square calculation is less than chi-square table value. We fail to reject H0. Otherwise, so or we accept H0. We conclude that there is no significant difference in the sampling techniques used by the researchers. That is independent. Difference ledu means no difference is what here. We conclude that is there any difference? No difference. Both are independent. Both are independent. Both researchers' sampling techniques are independent. This is the one problem here, chi-square. Second problem, I will give another problem is also very important for semester and examinations. So the number of scooter accidents per month in a certain town were as follows: 12, 8, 20, 2, 14, 10, 15, 6, 9, 4. Are these frequencies in agreement with the belief that accident conditions were the same during this 10-month period. So this is the problem here. Use in this one chi-square goodness of it. H0. The number of scooter accidents per month in a certain towns were as follows. In Vijayawada city, like this here. Are the frequency aggregate with the belief that accident conditions were the same during this 10-month period. First month, second month, third month, like this 10 month. Null hypothesis H0. Set up the null hypothesis that the given frequencies means accidents, number of accidents per month in a certain town. In Vijayawada city like this is a consistent with the belief that accident conditions were same during the 10 months for various reasons. So the accidents number frequency is same here. Based on hypothesis, you have to calculate expected frequencies. Now H1 is the given frequencies are not consistent the belief that the given frequencies are consistent with the belief that accident conditions are not same during the 10-month period. Step 1, step 2, step 3. Choose alpha 5% LOS. Next one, test procedure. Now step, calculate expected frequencies under H0 based on the H0. All conditions are based on the H0 is here. In 10 months duration, all conditions are same, but alternative not same. In this case, based on this H0, so you have to calculate the expected frequencies for each and every month. In this case, we have to add up all these numbers. You have to find out the average number of accidents for each month. Average number of accidents for this 10 months time, that is 100. Expected frequencies for 8th month, 100 by 10, that is 10. I is equal to 1 to 10. Second step, computation of chi-square value. How to computation of chi-square value? Here is month, first month, second month, third month, fourth month, fifth, sixth, 7, 8, 9, 10 months. Observed frequencies, OS. Expected frequencies, EI. OI minus EI based on the previous method. For goodness of it, for independence of attributes. So formula is different, procedure is almost all same. Now observed frequencies. Original accidents. First month 12, second month 8, 20, 2, 14, 10, 15, 6, 9, 4. Now, based on the under H0, we calculated expected frequencies for each and every month. The average number of accidents is 10. Now, this is the very simple technique. This problem also very important for data analysis and also examination point of view. Now, calculate OI minus EI. 2, minus 2, 10, minus 8, 4, 0, 5, minus 4, minus 1, finally minus 6. Now square of these values. 4, 4, 100, 64, 16, 0. Now 25, 16, 1, 36. Now 4 by 10, 4 by 10, 100 by 10, 64 by 10, 16 by 10, finally 0 by value 0, 25 by 10, 16 by 10, 1 by 10, 36 by 10. Sum of these values, summation OI minus EI whole square dividing by EI. I is equal to 1 to 10. This value is equal to 26.6. You may also add up numerators. 4 plus 4, 16. So 16 plus 64, 80. 180, 196, 196, 201. 41, 201 plus 41, 226 by 10, 26.6. Now, chi-square calculation is equal to summation I is equal to 1 to 10 OI minus EI whole square by EI. That value is equal to 26.6. All expected frequencies are more than 10. No need to apply the pooling concept. The degrees of freedom is equal to sample size minus 1. One constraint is there, that is linear constraint. Sum of the OIs is equal to sum of the I's. That is the assumption. Observed frequencies total and expected frequency total must be equal to 100. So whenever sometimes maybe is not equal, you make it possible to equal both here. That's why here n minus 1 is the degrees of freedom. So n minus 1, 10 minus 1. 10 minus 1 is equal to 9. Chi-square table value, chi-square 0.05 at 9 is equal to, so go through the table values. So table value is 16.919. So chi-square calculation is more than chi-square table value. We reject H0. We conclude that same statement is given here. We conclude that the statement is accepted. We conclude that the given frequencies are consistent with their belief that the accident conditions were same during the 10 months period. This is the conclusion, the final one here. All problems are explained. So go through these problems, you can prepare for your examination. All the best, students.